Our today's topic is AI in manufacturing industry. So before diving directly into the topic, I would like to give brief about myself, about my introduction, and the agenda which we'll be covering. Okay. Firstly, about me, I am working as a solution architect in aligned automation, and my overall experience is 13 plus in this industry, mainly driving business concepts into practical real world solution and having experiences overall different domains like construction, e-commerce, and manufacturing domain. So I'll just give brief on the agenda what we will be covering. So in this session, we'll be covering how the evolution of AI has been started, why AI is being used in manufacturing, what are the different use cases, and we will move ahead with deep dive on the specific use case. Now, before starting with this evolution of AI, let me ask you a question that how many believe that AI is meant only for tech companies? You can post that question in chat. Just open that chat. I don't think so. Okay. Yes, here. Okay. Okay. I believe that AI is industry agnostic and it can impact any industry which is truly in transformative. Now, coming to its evolution, here as I have listed 1950s to 1970s, there are early concepts of AI based on systems, symbolic reasoning. After that, machine learning gains has started and traction on that with neural networks, expert systems, but that has their own place in the industry. And after that, big data and cloud computing takes into the market, wherein many industries are working on big data, working on the cloud computation part and how we can accelerate that information. And starting from 2010s, where we say as Industry 4.0, wherein AI integrates with IoT, robotics, and edge computing. Now how this is taking into picture how we can use AI in digital transformation, whereas it enhances the traditional computing as well as leveraging different kinds of systems. Now, as I can say that manufacturing has multiple machines, it has different types of human labor coming into picture. There can be manual errors which can impact the efficiency of the manufacturing industry, where AI roles comes in picture, which will help the organization to grow, reduce cost, as well as improve the efficiency. And as we all know that this industry is having a data which is very sensitive. When we collect this data, this has a real time actions which we need to keep ongoing and impacting the decisions. Now, traditional data is there is some message. Okay, sorry. Traditional data sciences, which helped our industry with historical trends but lacked in real time adaptability. AI, on the other hand, enables predictions, which can give you real time analysis and helps user to give impact on the current ongoing situation. Now, this is also helping in our supply chain logistic as well as digital twin factory models for optimization purposes. Now, why AI? That's where we say real-time adaptability as well as automated decision making with IoT and robotics. There are many organizations here which has already started using AI in their industry, like we say BMW, Mercedes-Benz, even Mahindra. While when I visited Mahindra, they have started using this cobot for getting any detecting any issues which are there in in any of the cars so that it can be fixed easily before going on the road. This AI predictive maintenance also helps to fix machine failures before they occur. Quality inspection is one of them, and supply chain for risk assessment and the supplier selection. So that is what we are going to cover. Different use cases in AI in manufacturing industry. It's not about manufacturing, but in different industries that maintenance can be a challenge, quality can be a challenge, and logistic, as well as these three things: digital twin, robotics, and energy efficiency. These are the some of the use cases which can be applied on in manufacturing industry. Predictive maintenance, auto manufacturer, you can take an example of auto manufacturer where reduced equipment failures helps this manufacturer by giving the efficiency by AI driven predictivity of that maintenance. When they are gonna give the when that manufacturer company should go under that maintenance area, they could predict failures. So if my machine is going to fail by the end of next year, then this will give the predictive analysis based on historical data. Maybe we can consider 5 years of data or 2 years of data, but it gives us an analysis on that. Quality inspection can be a challenge in manufacturing industry. Like there are human inspectors which are dealing with this inspection detection of the issues, but manual errors can happen, and which may lead to cost efficiency and defect increasing in the defects. Supply chain, as I have already mentioned, supply chain gives optimization, helps in supplier selection as well as risk assessment. So we can go ahead and check with the risk which are already there, and supplier selection can be useful in procurement while taking the decisions in procurement. Digital twin technology is one of them by creating a virtual replica. And robotics and automation, as we have heard, that cobots are already there in the industry for data, for automating all the processes. And the last one is energy efficiency and sustainability. Energy efficiency is based, this is specifically meant for manufacturing for green initiative. Some many of us have read the term of sustainability in various areas, that we need to have our papers reusable, concept of reusability. So this is the where we can introduce sustainability, where I we can say that some of the hard drives can be reused by making it more useful, or by reutilizing or by giving the predictions using AI. AI driven energy management will help that a lot. Now we are gonna dive deep into these use cases, and one of them is digital twin technology. Digital twin is the concept of virtual representation on a digital space, wherein physical assets, like it creates a replica of a manufacturing factory. So let's take a scenario of Mercedes Benz or any of the car manufacturing company. It creates a virtual asset of a car, wherein we can go ahead and create, you look at the simulation, how it is working, how real-time data can be collected. And once we have all the data set ready, it creates a simulation and check each and every part of the car to give us if it is faulty or the machine is good enough to go in the market. This digital twin becomes more powerful for efficiency monitoring of the system and across various manufacturing processes like synchronization of the data as well as predictive analysis based on real-time data. If we are capturing real-time data from sensors, it gives it provides that to analysis and provides us a futuristic approach that we need to take a decision. It also gives us intelligent process optimization where AI analyzes that data and suggests some improvements to organization. Like if there are any bottlenecks which are hampering the situation of my car manufacturing, then I will reduce that bottleneck beforehand and proceed with by replacing that. It will also help in quality and detecting any defects which are there in our real-time data. So I would give you one more example. If chemical or chemical industry or any manufacturing plant wherein chemical values are being passed, and that uh, data is following it through real-time IoT sensors or any of the um, I can give you one more textile industry. So while going through a textile industry, there are various processes. So going through its color combination, we need to change its thickness, its color. So that real-time data has been captured, and there are various machines attached, starting from thread to getting it into a pure fabric. There are various machines attached, and those machines can is attached to sensors. From there, we can collect the sensor data. And this will also helps in sustainability for improving the efficiency of the application and energy consumption. I do have one more example on this digital twin where AI plays a better role. I can say earlier. So when you can also say machine learning can also do this, predict the some of the analysis as well as real time. But AI's role is based on historical data to provide analysis. It provides us it helps to get an efficient production process in this real world. This means that fewer costly mistakes and or it will help to optimize production cost and efficiency. There are various ways to improve the process with the help of AI by using self-learning algorithms and refining this factory processes with predictive scheduling. Now, coming to this business impact and what are the numbers which is impacting our industry, so which helps us 30% of reduction in making our systems down. So if my system is down and my AI machine will provide AI visualization provides us that this machine is going down will go down after a period of 6 months, then this will help to take decision at management level that at least we should look into this machine or change some parts, or maybe we can work on its servicing of that machine so that which will help reduction of its downtime. And it also saves cost. As per the current data in the market, it percentage wise, the data which I have got from looking around some of the websites or scrolling around, that 20%, it helps in 20% of cost saving, as well as the product quality also increased if we are servicing our machines and if we are analyzing any defects which are gonna happen in future earlier before time. This digital twin system also helps in scalability of the application. Let's say we are creating a virtual replica of a car or the factory model, then this where we are gonna deploy this application, how it will work. So that part is also taken care. Apart from this, workflow inefficiencies which are there in any of the model that will be handled, and those bottlenecks will be reduced. Simulation testing can be done with this digital twin technology, and if there are any adjustment needed, then that is taken place. As I have gone through one of the article, BMW's using this digital twin technology, which has 5% in production efficiency and 20% in energy consumption. So these are the numbers. The second use case, which we are gonna deep dive, is supplier selection and risk management. So what is this supplier? I'm talking about, you must have you must be thinking that why she is focusing more on supplier selection or risk management, what it has, why. So managing suppliers is mostly crucial but challenging in our day-to-day life. So consider the same scenario of selling of the cars or getting the raw material for car, for creating for production of the car, or any of the manufacturing industry. Raw material and its logistic can be a challenge. So dealing quality, there can be quality issue. If there are any delays in the logistic, then there will be a risk associated with the production of the product. Traditionally, supplier selection was based on historical data, but again, that is manual. And some of the machine learning models are also predicting us, but not on a real time basis. Now, coming to this AI 4.0, Industry 4.0 is adapting all this historical data with real time analysis. How this will help in supplier selection. So, if we collect data and integrate in our system, so supplier related data like supplier historical data, delivery timelines, past performance, quality, if there are any issues in the quality of the products or raw materials, then that will be highlighted with any of the key performance metrics, which will help to make the decisions. Apart from that, logistic is one of them. Shipment tracking is also possible. Warehouse availability. Let's consider one more scenario that if logistic is a challenge. Now, how logistic? During the festival season or during any of the long weekends. So what is happening? Logistic has disrupted a lot. So timely providing logistic to a manufacturing company is a challenge. Then they are using this dynamic switching of the logistic environment. So how they are selecting different suppliers from where we can get all the raw materials, and which helps in mitigating all the risks. It also combine all the data into different streams and give us a real-time dashboards. So supplier evaluation can be done on this, and it also helps in supplier performance scoring. So I have gone through one of the example wherein we can also suggest them different types of vendors who will be giving us a competitive cost. So if I am having four vendors, then one of the vendor is having competitive cost, then I'll go to that approach, which will help us in procurement domain. So based on time delivery slots, based on quality score, based on pricing stability, these KPIs can be generated using AI, and risk can be mitigated. Now, there are various examples on this risk mitigation, like contract optimization is also one of them. Supplier selection, as I have already mentioned, contract optimization, what it will do, AI suggests us better suppliers, and we can negotiate that cost with our existing customer, which will help us to negotiate and optimize the contract and make some modifications in the contract which are required. Even dynamic supplier switching is possible, where in real time analysis gives us if I can go and tell any of the vendor that no, this is another vendor is giving me different separate cost or low cost. Within that time, I will get my raw materials. So this dynamic supplier switching can be possible with this AI role. Now, how business is impacting those numbers, if we calculate, is 20 to 25% of supply related delays are there, which are forecasting the risk as well as helping us to go ahead for selection of better selection of the supplier. 15% of cost savings are there, and supply chain resilience can be helped. It can be made stronger in real time world. There are different companies where we can take an example like Ford is there, Walmart is there, wherein this supplier selection and risk management can be applicable. Hope I'm not giving more details on this industry. Let me just, okay. Now, as I have mentioned here, challenges and future trends. So while involving all this AI's role into manufacturing industry, there are various challenges like cost, high investment, and I can say is workforce is needed because technical upskilling is required. We need to be ready for AI implementation into our industry, and that much skills is needed. And what are the future trends and innovations? So AI plus IoT, which we are already seeing, is industry 4.0, edge AI for real time processing, smart factories. When we say that smart factories with AI, that is AI powered smart factories, and sustainability can be, we can go ahead and start innovating different use cases with this initiatives of sustainability, green AI, and IoT. Apart from this, as I am saying, future, this is AI is future for us, but not future. We are seeing AI is still, AI has started happening this right now. Companies have already adopted AI, and there are some of the industries which are getting help from this AI trends to increase their business. Any questions? I'll open this forum for questions. Just open.
Right, so there are no questions in the chat, but if in case if there are any questions, please feel free to come out of mute and then ask the question. Okay, there is first question in the chat. How is data feeding managed to digital twin? Is there a dedicated resource to log those details such as process started, ended date, etc.?
Digital twin, dedicate. This is simulation software. So through software, we can get those details. So IoT, if there are various tools and technologies available, cloud technologies like Azure, even AWS, and so Azure IoT is one of them where we can get all the data from this sensors and feed it into digital twin. So by connecting, there are connectors available, and then once we have all this IoT data, we need to structurize it and then process it further for analysis.
Okay, thank you. There is another question from Rahul. How realistic is the cost consideration for AI implementation, given manufacturing is very cost sensitive?
How realistic? Cost consideration for AI implementation. It is a little bit costly, I can say. Means whatever I have gone through the articles and read through all the papers, industries which are they are using it, it's a little bit costly because they have to transform their existing infrastructure by adopting with sensors, getting that data collected, and cloud cost is already as already we know, cloud is very costly to transform all this sensor data and proceed further. And as after that, the AI models costing also impact over there.
Yeah, thank you. There is one hand raised by Sunil. So Sunil, please come out of mute and then maybe ask your
Yeah,
question.
yeah. So, in
Yeah.
this industry, manufacturing industry, are there any concerns over data privacy? Because the models that we use generally, OpenAI, Claude, and all,
Mm.
does have the privacy concerns. Data might get used for training. So, is there any concern in manufacturing industry?
Right. So security is a challenge. So we need to have our own models, because if we try to go ahead and use open AI keys, so that data is not secure, then it will be in their hands to use that data and proceed further. So if we are thinking to have our model efficient and secure, so it's better to have deploy in our on-prem infrastructure and then train it.
Right,
One more
hopefully
question.
that answers. There is another question from Rahul. Is there any data set available for the IoT data? Some sensors, he assumes. And if I want to implement some ML models for predictive maintenance.
Just a second, is the data set available? Yeah, there are many sample data sets available in the market. So if you go ahead and search sample data sets on Kaggle, that will help you.
Okay, thank you. There is another question from Pranay, even he had got hand raised. The question is, apart from sensor, which data we hooked up in digital twin? But Pranay, please feel free to come out of mute and probably add.
As far as I know, mostly IoT data, that is the real-time data which we can capture for simulation. If there is anything, then I also need to go ahead and check.
So, Sailee, this is
Yeah.
Pranay. So basically, I just want to know which digital twin you have created till so far, for
I
which
haven't
machine,
created. Uh,
for which machine, for example, compressors, or which machine you have created.
So Pranay, I haven't created any digital twin for any of the compressors. These are the solutions which we can give to multiple different types of use cases. So no, we haven't
No,
created anything.
so any you have not created any digital twin till so far, right?
No, no. So it's like capturing IoT sensor data and then predicting it. That is possible, but not on that digital twin level, wherein I go ahead and give. We are here, so we give only solution to the organizations wherein this what is adaptive, what can be used, and how it can be used.
Okay. So I'll
Yeah.
give you one example. For example,
Mhm.
for any chemical industry, okay,
Hmm.
there are air separation units are there where they create a industrial gases, okay. So they
Hmm.
want to create a digital twin. Now,
Hmm.
what is the critical component in the process? Because the cost wise also, if that component cost is more than 10 crores, then probably you can make sense of that creating a digital twin. Otherwise, they will say that, what is the license cost for your, right? So otherwise,
Right, right.
the industry will not, or that plant will not accept it. So you have to
Hmm.
be very fair about the cost and the efficiency. Then for the compressor as well, you need to create for compressors, you need to understand the vibrations first, and
Hmm.
then you need to understand what are the failure components. Okay, if you tell that plant head that these are the failure types, I can predict it, then only they can rely on your words. Otherwise, they will not rely.
Hmm. Hmm.
So
Agree. Agree.
Yeah, so that data you will not get only from the sensors, you will get from the process historian. Okay, so in
Okay.
any plant there is a PH, process historians are there, of Aviva, of Siemens. That data they capture it already. Okay, from that process data and the sensors for the vibration, for the critical processes or critical like a temperature. There could be a temperature, there could be the pressure. Okay, and they are correlated with each other. Okay, then only you can understand. You need to understand their process. Then only you can
Right, right.
create a digital twin and the predictive analytics of. I did it for 2 or 3 customers. That's why I'm saying.
Okay,
Okay.
okay.
Yeah.
Thank you.
Thank
Yeah.
you. Yeah. Bye.
Yeah, thank you, Pranay, for adding those. There is another question from Vinod. He is asking what are the different drivers to move to AI in manufacturing? Is it just cost efficiency or anything else?
So it totally depends on the use case. Cost, yes, obviously, cost will impact us, but factors needs to be considered. For example, if we need to check risk of the any of systems, or if we have to go ahead and resolve human errors, if we have to focus more on detecting defects which are happening on the systems. So there are various things which needs to be thought about before proceeding with AI on any of the in manufacturing industry. It's not only about cost.
Okay, thank you. There is another question from Rahul. Can AI help in customer support in this sector? Is there something like this already existing or used by companies in manufacturing sector?
Customer support, yes, I can say, like Chat GPT. So same type of model can be created. Chatbot can be created, which will help custom support people to give us the recommendations if they have faced these issues earlier, or I can say through various historical data, they can read it and provide all the recommendations. So I answer is yes.
Thank you. There is another question from Sunil. Like, is there any special LLM model which is trained for manufacturing process?
No, I don't think so. Is there anything special? We
I,
have to work on its
I need to
customization.
answer. I need to
Yeah,
answer this, Sailee. There is an industrial
yeah.
co-pilot is already there. Okay.
Hmm.
But specific to the certain plant data. Okay. But you can't rely on that still so far.
Yeah,
But basically, you can get operators can get a help from this. Okay. But you can't rely and operate the plant till that is not till matured. But
hmm.
yeah,
Right.
there is work is going on.
Okay.
Yeah, and I'll just add on top of it because that's what my guess was, because the LLMs, all this industry data is private, so AI is not
Hmm.
already trained on it. So you got to have a model trained privately, and
Right,
that is
right.
a huge cost upfront capex itself, even before
Hmm.
making any use case and prove it to be efficient in process or any other this thing. So I think this could be the one of the biggest challenge, the capex needed and the tech and people needed to even set it up to showcase it.
Right. I agree on this because as far as I know that we need to work on its customizations because it totally depends on industry to industry. Industry has their own type of data with the various challenges, and we have to make our model work based on that data. So yes.
All right,
Uh,
so that was the healthy discussion. But yeah, Miss, again, apart from that, if there are any more questions, please feel free to drop them in the chat or maybe please come out of mute. And yeah, Miss, this session has been recorded. Recording will be available onto our YouTube channel. Thank you. Probably I will just stop the recording. And if in case you have got any questions, please still feel free to ask or maybe type in the chat.